Um, the first time I come to Gothenburg, it's a beautiful city. Really impressed. Like it a lot. Definitely coming back for like a weekend or something. But tonight I'm going to talk a bit about continuous delivery using continuous pipeline that's kind of agnostic to technology. So you can run basically everything that runs on top of Docker. That's basically everything that runs on top of Linux. And using Jenkins and Job DSL. I'm Camilo. I work at Klarna in Stockholm. Previously, I was working in Brazil for ThoughtWorks. And yeah, I have been doing continuous delivery and testing most of my career and some Java development. But I'm not that much a Java guy. But I hope you don't ask a lot of questions about Java tonight. And yeah, I guess everybody knows Klarna, right? It's a financial company. We do online payments. We are trying to simplify buying, so the goal is basically to remove everything from like you and your goods. So you just click once and then you get your goods in paying 14 days. Oh, it's quite loud now. Okay. For the ones that want to dirt hands with some Docker and some Jenkins, you can check out this repository on GitHub. And I would like to know how many of you never used Docker before? Good. So that's your chance. Do it. It's awesome. And you know why it's awesome today. And how many of you use Jenkins today? And what would happen if your server or your whatever machine that's running the Jenkins just burn and you have to do it all again? How many hours do you think you would take to do that? So yes, a lot, right? Hopefully after this you will have some guidance to start doing something and avoid this kind of problems. Well, we are going to talk about continuous delivery, but why continuous delivery? And then two of my favorite things about to explain why continuous delivery is like the risk of having an issue in production. So as long as you take to deliver something to production, it increases the risk of having an issue in production. So if you deliver after 1 month, you probably have some issue there, and then until you find it, it's going to take a while. And the second problem is not only it's higher probability of having an issue in production, but also it's a lot harder to find it since you have a lot of changes instead of small changes. So to avoid this from happening, we start using continuous delivery. So it's better to ship code to production often than just keep it from going to production and shipping it later. And a big example of this is like even a small change, like how many of you heard of the go to fail bug from Apple? I think it was last year. Pretty shameful, right? Yeah, there was a small issue, and even though they didn't get it. So tonight we're going to talk a bit about how to avoid this from happening. Everybody's familiar with continuous delivery pipeline or like a delivery pipeline? Yes, I'm not going to talk a lot about how it should be, like what steps you should have, because it's pretty much defined by the team and their needs. I'm going to talk more about how to build this pipeline. But there are three things that I think that's very important for us to have it. So a pipeline is basically a way to encapsulate the problems in different steps or in different phases, and then you can just deal with these problems. And you can have a package, like that small package there, going up to a stage where you can ship it, and you can reduce the risk through each one of the steps. So if any of the steps fail, you know exactly what's the problem. If it's like a performance issue, if it's a security vulnerability that you're introducing, or if it's a functional bug, for example. Well, the three things that I think that are very important about the pipeline are, first is like to have independent steps. Back in like some years ago, when we used to use continuous integration purely, it was like everything in one job. And why it was bad? Because the job was slow. When it fails, you never know what's the problem. You have to go and check on all the logs and find the problem and fix it. And then if you have another issue, like 3 steps ahead, you would have to go there and fix it again. And it's a lot of work, unnecessary work. So if you can just encapsulate the problems and run it, each one in one step, it's much better. You have a deliverable, and this delivery should be built in the very first step. And then you use this one. So for example, if you deploy your application as a RPM, you create an RPM in the first step, and then you install it, and you run it in all the other steps. So you don't only make sure that your code's good, but also that the package that you deploy is good. The same thing if you run containers in production. The same thing if you have some JavaScript package or anything, like anything that is whatever is your package, create it in the first step and promote it accordingly. And the third and not least, if you run your pipeline with the same code 3 times or 100 times, you should have the same results. So avoid steps being red sometimes and being green sometimes. So this is pretty much what we are going to talk about, how you have to design your pipeline. Now we're going to talk about what you can use to design your pipeline and get those 3 examples in a good shape. Well, you can choose among several tools in the market today. Some are open source, some are just free, and some are like proprietary and you have to pay a lot of money to use. Here are some examples. So you have Travis, you have Electric Commander, you have ThoughtWorks Go, you have TeamCity and Jenkins and many others. Tonight we're going to talk about Jenkins. And we're going to talk about Jenkins for 3 reasons as well. The first one is it's a very community design tool. So the community contribute to it a lot. This picture was taken a few days ago to the next day presentation, and probably if we go there right now, we will see commits from today being merged. So it's a very active project, and the community guides how it works. So for example, what makes it better, in my opinion, than proprietary tools is that the proprietary tools have a lot of the view of the company behind it. And Jenkins is much more like good practice from everybody. So you can design and choose your spices, and you have the Jenkins as you want to have it. The second one is the support for many tools that are either proprietary or open source. So you have integrations with Stash, GitHub, Slack, and several tools that you can use to support your communication and your engineering inside your company, and you don't have to choose the continuous delivery tool because of that communication tool that you use. You can choose whatever communication tool, and it's probably going to have support for Jenkins. And third, and one of the most important, is that Jenkins is pretty much the only one that I tried that has a really good support for automation. And when I say automation, I'm talking about designing your entire pipeline in a way that if something goes wrong and your machine just burns, you can have a new pipeline running in 5 minutes. If you have a good internet connection, of course. But even though when you go and you search for Jenkins online, you pretty much have a picture like this. So you have Jenkins that you have to go through the GUI and write all the jobs that you want to run, configure everything manually, and for each one of the servers that you use, you have to have Jenkins agents that have the infrastructure or the components that you need. So if you want to run a Java application, you have to install the right version of Java in a machine. And if you want to have something running in a Ubuntu, you have to run it. You have to install Ubuntu and then provide this machine to Jenkins. So there are a lot of ways to configure that. You can use orchestration tools, such as Puppet or Chef, Ansible, or whatever. But even though it's quite painful, because you have to deal with like APIs for your cloud, and then APIs for for those tools, configuration and everything. And I had really bad experiences with Chef. Then I just avoid this kind of stuff. And yeah, so the problems, the main problem is like the configuration for the nodes. So you either use some orchestration tool or you do it manually. If you do it manually, and for some reason you just forgot to change the sleep time for the Jenkins and it kills the agent, then you have to go there and do it again. If you use some configuration and it's downloading stuff from the internet, for example, and it's offline, like some Maven package or some operating system, some website changes a URL, something, you screwed. You have to go there and change it again, and it's kind of painful. And the Jenkins itself, it's kind of an old tool, and it has one of the things that everybody here loves, that's XML. Yeah, so I grow to have allergy to XML, then I just don't like to keep it on Git and do my changes there. It's kind of painful. So how do we solve these problems? Well, there are two tools that we can use to solve these problems, and each tool is focusing on one of the problems. And the first one is Docker. For the ones who don't know Docker, Docker is kind of the new hot tool that everybody's talking about. Personally, if I could, I would use Docker to make coffee at home. Unfortunately, I can't yet. But Docker is basically like, if you see this picture, it's pretty much how virtualization works. So you have some infrastructure that could be a computer, could be a cloud, could be a data center of your own. And then you have a host operating system. And on top of it, you have a hypervisor. And on top of it, you have guest operating systems. And each one of those operating systems is going to run the libraries that you want to run, and it's going to run the application that you want to run. So it's pretty good, right? Except that if you're running, for example, in your local machine, 17 different services, you need to have 17 different operating systems, or you have a completely different picture of your system, infrastructure and microservices. Then what Docker does is basically cut half of the problem. This is a picture of Docker. So you have your infrastructure that could be any of the infrastructures that we cited before. You have an operating system, and then you have a Docker engine. But here comes the magic. You don't have a guest operating system. You only have your libs and your application running in a different. It's kind of a process, but it's encapsulated in a way that you can have some network-ish interface among the the processes. And that's really great, and we are going to talk about it in a second. So when you use Docker, you're not only emulating, you're not giving up on having the hardware, but also to have the operating system that was running before. And everything that's needed to run the application that you have, the applications that you have, is shared among the operating system that you have in your machine. And you don't have to care about having a different operating system for each one of the processes that you're running. So you have an abstraction of operating system, and it's really great. Here are some examples of things that you can run on top of Docker. So if you want to use Ubuntu, you can. If you want to use Tomcat with Fedora, you can. If you wanted to use the Nginx, or if you want to run Cucumber tests, or if you want to run Gradle, or even if you want to run Docker or Linux containers, you can run inside Docker. Ruby, Erlang, Node, any language that you can run in Linux, you can run there. And sorry, someone's asked something. Oh, sorry. And that's quite powerful, right? How the magic works. We have this hub.docker.com. That's basically where you can have all your containers. Oh, sorry, all the images that you can run with Docker. Or you can have your own hub, and you can share like images for the applications that you have in your company. And for images also for like base Java, base Ubuntu, base whatever. And you don't have to go to the internet and download it. It's like a nexus for Docker images. So you just have several images there, and then you just download it and run it. Here's examples of machines that are in the official Docker registry. So you have, for example, Ubuntu, CentOS, and if you go there, you have pretty much machines for a lot of stuff. And you even have companies that are providing, like Klarna provides some container, some images, and you can just go there and run it. But how hard is it to run Docker? So let's suppose that I want to run Gradle. What I have to do, if you have Docker installed in your machine, you pretty much do a Docker pull, get the image. Here I'm going to be verbose because you can just do a run, and implicitly, if you don't have the image, it's going to pull it for you. But you basically pull the image that you want to run, and then you run a command. Of course, you have to share a volume, or you have to add some code to the image to run it. But we are going to get there. And then in the same machine, now you change your mind, you want to run some Ruby commands, and then you can just pull the Ruby image and do the commands that you would do like if you had it. Or nodes, or if you want to run an application like Jenkins itself, you can just run the Jenkins, and it has a kind of a recipe inside that runs everything for you. Or if you want to run Git or any other tool. Not only that, but Docker comes with some plugins, and one of the plugins that's pretty much the one that I like the most is the Docker Compose, and I like it because it gives you like a power to spin cloud-ish in your local machine. So if you want to emulate, for example, a Nginx node proxying information among 3 different nodes for Drop Wizard that are using a MongoDB, you can do that with a simple file that looks like this. So in this file, we have like 3 different nodes. If you can see on top, Nginx, and then you have my service, and then you have database. And you just tell where to build the Docker file, and you create the links there. So when you say links, like we have here and up there, you're creating a network access from one container to the other. And the good thing about it is that if you just do a Docker remove, and you will not have it anymore. So your machine is clean from day one, and you don't have to care how many services you're running, because like it's not actually installing anything in your machine. And if you're doing like tests, it's really great. So a very smart guy in the Middle Ages said, one image to run them all. His name was Sauron. And this image is basically composed by Docker and Docker Compose. So you only need to have for example, Ubuntu machine that runs Docker and Docker Compose, or a CentOS machine that runs Docker and Docker Compose. And you can run any kind of cloud that you want to run in a single node for Jenkins. And just remember, when we talk about infrastructure, it could be you could have a single machine running in your company that provides all the containers, or you could have Amazon machine. You could use AWS to run the containers, or you could use Google, or you could use anything. Yeah, so AWS is one of the ones that's providing it already, like some ways to run containers. Google as well, we're going to talk here, yeah. So you have Kubernetes. You have, even Microsoft is doing that. Never used, but they say they are using, they're providing it. Mesosphere, Rackspace. So all the big companies that provide today some kind of virtualization, they are also providing virtualization for containers, containerization. They are kind of trying to create a new word. I don't know how it works. Well, but then we have half of the problem solved, because the Jenkins itself, it's still messed up. It's still a lot of XML or a lot of GUI that you have to go there, click around, and configure it. How do we solve this problem? How many of you never used Jenkins before? So, okay, I'm going to give you like an introduction to Jenkins, how wonderful it is. So if you want to change a job, you go to this amazing, beautiful UI. Very modern, like using Twitter Bootstrap, probably. And you click there. Then you have the job itself, the task. And you click in the configure link. And then you have a very nice form here that you can go and change a lot of stuff. And when you are done changing it, you click and save. It's quite easy, but then imagine that you have 90 jobs that you have to update with, for example, a log rotation, because you find out that the Jenkins is running out of space, and then you have to clean it every time you run the jobs. You have to go and do it 90 times, and it's quite painful. That's why we looked around and we looked for some solutions to automate Jenkins. And there are quite a few, actually, like template project plugin, job generating plugin, the job builder that actually is a lot of XML but a bit more readable. And we have the Job DSL plugin. That's the one that we are going to talk. And we are going to talk about it because it's groovy. While the job builder, it's a bunch of XMLs that you have to go and configure all the time, and then you have to keep track of it. And if you need to change something, you have to go in each one of the XMLs and you have to change it. The Job DSL is quite flexible, and you can do whatever you want to do with Groovy. You can do to change the scripts, and it's going to, of course, create the XML that Jenkins reads. And this is an example of how easy it is to understand. So you have a job, and then you have an interface for dealing with it. That's very simple. So you just add the information that you want to have, and it generates for you this XML. And I'm cutting half of it because it was a lot more. But then this is what Jenkins actually reads and shows in the GUI and runs behind the scenes. And this is a more sophisticated script, and I'm going to show how it reproduces itself on the GUI. The first command creates the project name. And then if you check SCM, it stands for source code management. That changes the source code management. And you have the Git that changes the Git. And then it's a very readable and very easy. If you use with Jenkins, if you have experience with Jenkins, you see that the names are quite good. And then the URL is the repository URL. When you create the trigger, for example, it's a pull trigger, and then you just set the information there, and it's going to create it for you. The steps are the shell steps, the build steps. And each one is going to create a different execute shell, for example, and in the sequence that you provided. And the publisher goes for the publisher actions, and it's the same thing. Like if you have a report, then you just use the word report, and it's quite good. Like Jenkins has hundreds of plugins, and the Job DSL has support to many of them. Not all of them yet, but for many of them. But then there is still some things that could be improved, and that's why we use Groovy. So one thing that we realized, like after having a lot of those jobs in that format that the Job DSL provides to us, we start thinking about it. Okay, so if we have it, why not start like using it in a nicer way and using it with Groovy itself? And the idea comes for building a project instead of just using a bunch of scripts. And here are some advantages that we have. The first, and the one that I like the most, is that you can have tests. Because if you start having this kind of automation, and then you just mistake by adding like something wrong in your script, you're going to break your pipeline, and you have to find it and fix it and everything. And if you're writing a new job, you probably want to see how it would look like before you have it in your production pipeline. And that's how tests going to support you in this case. Not only that, but it's groovy and it has a really nice support for Spock. How many of you have tried Spock here already? Yeah, Spock's really great. I really like it. So with Spock, it's like for the ones who have had some experience with Ruby, it looks pretty much like a mix between AirSpec, because you have the definition of the method with something that's readable, and you have the given when then that you have in Cucumber, but you don't have all those verbose lines that you have there. And it has a lot of support for data-driven tests as well, so you can have many tests running in the same scenario. It's really powerful. Another thing is for the ones who like IntelliJ or Eclipse or any kind of IDE, it gives you support for the whole thing as well. So you can just go to your IDE and you can start coding in Jenkins Job DSL using the methods that it provides. And of course, like if you have, for example, a add step, you can decide how you want to add this step. For example, if you're using Docker and you're using the old version of the Job DSL, like without any automation, you would have to add the Docker command before each one of the commands that you want to run in shell. It means that if you have to change it in the future, you have to go to each one of them and update the Docker image, for example. Or you have to go there and update whatever kind of wrapper that you have around your command. If you have add step method that actually adds the wrapper for you, you just change it once. So it's exactly like any programming language. Like you can do whatever techniques you want to do, and it's going to work as well. And you can have something like this. You can have your own DSL to create the jobs the way you wanted to create it. This is an example that we have in the CDZ, the Git repository that I talked before. If you want to go there and check, it's not the really beautiful code. As I said, I'm quite new exposed to Java, but I think it's worth checking. And then if you want to do some improvements, pull requests are very welcome. And of course, like you can test it as well. So since you have, you can continuously integrate it as well. So every time you change your pipeline, before actually upgrading it, you run all the tests and you check if you break something. If you break something, it's not going to run. It's not going to break your pipeline. It's going to give you a chance to go back in time and fix it, and not break your pipeline. So you keep always the latest version of the pipeline working. Of course, if you don't miss any test, what could happen? So when we do that, we go from pretty much old version of Jenkins, like everything manual, and a lot of nodes that are manually or like orchestrated in some way, but are very, very dependent on technology, to something that's like a super Jenkins with magical machines that can run basically everything. Not that magic, like it's just science. But yeah, but you can basically run anything you want to run. And if you need to add a new service or a new mock or whatever, you can just run it on top of the same machines. You don't have to care about installing anything. You just use the Docker image that you have. This is from an internal presentation that we gave at Klarna 1 month ago, when we were presenting to the whole company how our pipeline works. I just salted some information here, so it looks very fakey, but it's actually a part of the code that we have there. And the thing is, the project that I work with, it's the Klarna checkout for the Java platform. And it's basically a service that has like 17 other different services that provides information, like risk assessments, user data, everything that can be used to improve the client experience. And then we provide it to the front end, and the front end uses it. So we are basically the first line service that's exposed to the world. And we also have some other microservices that work with addresses and credit cards and everything. We had to introduce a new microservice, and we like the way we test today. We like the way we promote the RPMs and all the data that we need. And to introduce the new app, we just added that line there, application 5. And we provide the name of the application, the GitHub URL, the name of the project, and what job we want to run, what jobs we want to run. And then it creates a pipeline for us that's identical to the other pipelines that we have. And we follow conventions and the tasks that we have. So we use Gradle, for example, Gradle, for example, and we have the same names to all the servers that we have. So with this, it's very easy to maintain a pipeline that's reliable enough to just add with one line and have all the tests and builds and everything running. So this was one of the most nice things that Jenkins Job DSL promoted to us. The other one was an example that we already discussed. The people from support told us that, hey guys, your Jenkins is running out of space, and you have to add the log rotation to your jobs. Otherwise, you have to just destroy the machine and build it again. If we didn't have Jenkins Job DSL, we would have to go over 90 jobs and change in each one of them manually the log rotation. And with this infrastructure, we just added in the create job method one line, and we create this method that actually uses the interface for the Jenkins Job DSL called log rotation, and we added it to over 90 jobs. And we make sure that all the jobs that we create from now on, we will also have the log rotation. So it looks very small, but it's when you're dealing with a lot of microservices and a lot of pipelines simultaneously, it's very rainful. If you want to learn more, I recommend you to check out the example that I built that it's called CDeasy. With this, you basically install in your machine Docker and Docker Compose, and you run the /setup shell script that you have there. And then you see, hopefully, if the internet allows, how it works. Also, you have a playground for the Job DSL. So you can just write your script and you run it, and it's going to show you the XML that you will have, or it's going to show you the problems that you have in your script. So you can just build something there, try it, and check if it works before you have it in your pipeline. And you also have the Jenkins Job DSL reference for all the methods that you can use. And it's actually quite well documented. You can also check it. It's really good. Yeah, let's try to demo, and let's see if the internet is working for us today. Okay, looks like it has downloaded. So I just saved some time, and I run the .setup script. Can everybody see it? And what it does is basically create a seed job for you. And we call it seed job because we should execute it, and we should have at least one extra job as a result of it. So I'm going to run it, and hopefully we will see something nice happening. Yeah, I just ask for a bit of patience because it's going to download some Java stuff. So as I said, in my machine I don't have anything, so I'm going to do a Docker pull in this Gradle image and see if it works. And then from the Docker pull, I'm going to run a command for the Gradle, and here is the command. So I'm passing this directory, that's my home space seed, and I'm adding it to the app inside the container that's running um, the Gradle. And I'm setting to the entry point Gradle, I'm saying, run please build. And the build is going to download everything that's needed, and it's going to run the tests, and it's going to check if everything is working. And then it's going to proceed to the Jenkins Job DSL script that's going to generate several jobs. If we go back here, now we have several jobs. The only one that was executed yet was the seed job. But if we go to any one of those jobs, for example, and we check the configurations in Jenkins, you'll see that we have a repository for each one of them, and we have commands, and all the commands are running exactly like I said. So you have a Docker pull, and then you provide a workspace with whatever code you need, and then you just run the command, the container that you download, the image that you download, and you run some command for that language or that framework, whatever. And if we go back here, we have a dummy pipeline that's not built yet. So to build it, we have to run the first job. And the first job of our pipeline is the unit test. If I go to the dump pipeline now, and I hope you can see it, I'm going to reduce the size a bit. So we have an actual pipeline running a lot of stuff, and everything here, like the jobs are empty, and they only have a sleep from 5 to 10 seconds. But it's just to show you that we can run a pipeline that looks really nice, and you can do whatever you want to do. For example, you can have several different stages with several different tasks. And for example, in the second column here, you see that the jobs are going to run in parallel. In 5 seconds, maybe. This is called the Delivery Pipeline plugin. And it has really good support for Jenkins Job DSL. I can show you how it works. And then here you have like 4 jobs waiting, and we have 2 Jenkins agents, and it's going to run 2 of them. If it updates, yes, it ran 2 already, and it's running the other 2. And it only goes to the next stage if all of them are green. So you can have decisions on top of whatever whatever performance or service level test you have. If any one of those fail, you are not going to promote RPM in this case, for example. And well, there's 2 ways of, and also like the pipeline supports 2 different things, either continuous delivery or continuous deployment. So you can just do deployment as soon as you get to the last stage, or as you're going to see here, you can have a manual trigger, so you just click there and then you run the script to deploy your application. So if you don't want to deploy something during the Black Friday, you don't need to. It's not that you don't trust your tests or your pipeline, but Murph is there, right? So in this example, I think we're going to deploy to beta, but we're not going to deploy to production. No, we are not going to deploy to anyone. And then you have a trigger, for example, and you just click here. But you can have it in any step of your pipeline. You can build it the way you want to build it. You can have all the steps in parallel. You can have some steps in parallel and some steps being triggered manually, and then after that, a lot of automatic steps. You can have a lot of stuff. And if you're using Docker, and for example, in here you're using Groovy to run your test with Spock in a Java application, and here you're using some C library in a Java application or in a Ruby application, whatever. And here you're using like JMeter or Gatling, that is Scala, or both at the same time. You can run everything using Docker. It's quite great. And even for the deploy parts, for example, to deploy to AWS, you can have a container that you just share the credentials temporarily, and you don't have to save the credentials anywhere. You just use the credentials plugins that Jenkins itself gives to you, like this. and you can consume the credentials from here, set it to the container very easily, and just after that the container disappears and no one can get the credentials from there anymore. So I can try to run some of those jobs here, but they are going to pull the containers, so I'm not sure if they are going to run in a feasible time. How much time do you have yet? 10 minutes. Oh, 10 minutes. I hope it's enough. I don't know any good jokes, but
Job DSL.
yes.
You did a Groovy to XML. Can we do XML to Groovy as well?
I'm not sure. I would say probably not. I think no. I didn't see any way to do that. Yes, I can. Yeah, I can show you. So here I'm inside a Docker container. Oops, sorry. Can you read it? Okay, I hope you can. Okay. So yeah, let me go again. So the first job that we run, the seed job, it's. I can show it in IntelliJ. I think it's easier. I don't know how to. Okay, let's go BI. Someone knows how to make it bigger?
Command and then scroll usually works.
No. But yeah, we have here Jenkins, Docker, and then yeah, the Docker Compose that we have here. That's the one that I told you that can do some network-ish. Even if you're running just one service, it's really cool because you can have it in a very readable way. So the ports that I'm exposing are those two ports. And in the Docker Compose configuration, it means that my local port here is the one that's going to be exposed. And this one is the port that's running in the container. So I don't have to expose all the container ports to my local. I expose only the ones that I want to expose. This should be avoided. If you start reading about Docker, you understand why, but it's basically giving privilege for your container to run some parts of your guest OS, so it should be avoided. But that's just an example, and that's fine. And then, like here, it has sudo power and everything. And here is where we are building the machine. So what I'm doing here is basically when I do a Docker Compose up or Docker Compose run, I'm going into Jenkins and I'm getting the Docker file. And this one's a bit ugly, but it's still easy to understand. So from Jenkins, what it does is basically it goes in the Docker Hub here and Jenkins. It gets the official Jenkins image, latest. You should pin the images, especially if you're doing a demo. I'm not doing that. I like to live dangerously. And then I'm using the root and installing some libraries for Linux that I need. And then I'm installing Docker and Docker Compose. And here's the magic for doing some automation on Jenkins that are not into the Jenkins Job DSL. For example, installing plugins in the Jenkins is as easy as using a file called plugins.txt that you just describe what plugins and what versions do you want to use. So every time that you start Jenkins, you just get all the plugins and install automatically. And then we are creating a seed job, and the seed job is a Groovy script that's very ugly. And I can show you here. Seed. Not very readable, kind of, yeah, not beautiful. But then we just keep this one like this, because then we create the infrastructure that we need to run the Job DSL that's much nicer. And then if I just destroy my machine and run it again, I will have all the plugins installed and everything running as fast as my internet can provide. The jobs must have run already. Yeah, so we run some, is it Java? Yeah, Java. So we're running some Cucumber tests in parallel here. And it's downloading Maven stuff, and yeah. And then executing examples here, and then I have a nice HTML, if I go back. Sorry. If I go back here, I have some nice Cucumber report, for example. And in a machine that has nothing, basically, it doesn't have Java, it doesn't have any library installed or anything. It's just running it. And in the same machine that also does not have Ruby, if I go to the run Ruby, and I check the console, yep, I'm running Rake and installing gems and running aerospec tests as well. And it could be anything. It could be JMeter, it could be Gatling for Scala. So if you wanna, like if you're introducing new services in your microservice infrastructure, you can just add the service with the test, and you don't have to care about installing anything. You just go there and pull the image that you need. And you can build your own images, like I showed before. It's very declarative, it's very easy. There's no nice way to test it yet, but once you have it, if you test it once, you just make sure that every time you rebuild it, it's working. But has a bit to grow yet. Docker is a quite new technology, so it's going to get better soon.